In this video, we will discuss how to solve logarithmic equations. There are two types of equations. One type of equation is when you have a log on one side and a number on the other side. Another type of equations is when you have log on both sides of the equation. In this video, I will stress on the first part, which is having log on one side and a number on the other. Let's start with example number 1. Log base 7 of x equals 2. The first step is to isolate the log. So let's highlight the first step. Always isolate the log. Now, as you can see, this step is done because the log is by itself. Log base 7 of x equals 2. My next step is to change to exponential form, which means if you have log base b of x equals y. To change to exponential equation, you take the base, you raise it to the y power, and that is equal to x. So b to the power y equals to x. This is how we do a second step in such a type of equation. So let's look at the base. 7 to the power 2 equals x. I changed it to exponential form. Now the third step is definitely to solve for x. So 7 to the power 2 is 49, so x equals 49. Now remember to always check your solution. So what I would like you to do is to go to your calculator and plug in 49 for x. So log base 7 of 49 and see if this is going to give you 2. If it does give you 2, then your solution is correct. This is how you solve the first problem. Now let's move on to the second problem. Isolating the log is my first step. So as I can see, I have log base x of 27 on the left side of the equation. So the log is by itself. So my next step is to change to exponential function. So x to the power 3 over 2 is equal to 27. Now how do we solve such a problem? Now when you have a power, to get rid of this power and get x by itself, you raise both to the reciprocal of that power. So let's write the word reciprocal. So what's the reciprocal of 3 over 2? It's 2 over 3. So to get rid of the power 3 over 2 and get it x by itself, what I would do is I would cross the 3 over 2 and raise 27 to the power 2 over 3, which is the reciprocal of 3 over 2. So x is equal 27 to the power 2/3. Now put this on your calculator and you will see that x is equal to 9. Now remember, if you would like to have an equation, to click on alpha y equals enter, and then you will be able to type in a fractional power or any type of fraction. So 27 to the power 2/3 on the calculator will be 9. Now this is how we do a problem like that. So remember, if you have a power and you want to get rid of that, remember to raise the other side to the reciprocal of that fraction. Now let's move on to problem. Now problem number 3 is a good indication of not just following the rules blindly. As you can see, the log is isolated, so this step is done. Now let's see if I change it to exponential form. Will this help me? 2 to the power x is equal to 64. So now x is in the power. What can we do in this case? Now, is there an easier way to solve something like that? Absolutely. You don't have to change to exponential form. As you can see, they're telling you that x is equal to log base 2 of 64. So why don't I just put this in the calculator and find the answer? Now to do that, remember we learned something called change of base formula. Or simply it's using log, common log. Change of base or use common log. They mean the same thing, more or less. So use common log. So what you do to get x is you go to your calculator and you plug in x equals, you don't have to put x equals, but on your calculator you put the log of the argument, which is 64, over the log of the base, which is 2. Now don't forget, that you can write a fraction by going to alpha y equals enter. You put this in your calculator and you will find that the answer is 6. So x equals 6. So in a problem like that, don't just follow the rules blindly. If you have x equals to whatever, just put that in your calculator and you can find the answer. Now let's move on to number 4. Now here, I see a common mistake that a lot of students do. What they would do is they would add 9 to both sides, thinking that they need to move 9 to the other side, but that's not correct. Why? X minus 9 is inside the parentheses. Okay? So, x minus 9 is part of the log. So log is actually isolated. In this case, there's nothing being added or subtracted, there's nothing being multiplied, so log is actually isolated. To solve then, this I have to change to exponential form. So 2 to the power 4 equals x minus 9. Now to solve for x, find what 2 to the power 4 is. So 2 to the power 4 is 16. You can use your calculator to find that. Equals x minus 9. Now to solve for x, you add 9 to both sides, so x is equal to 25. Now again, I need to remind you, once you find the answer, always remember to check. So what you would do is you would go to your calculator and plug in, not in y equals, just like on the main screen, log base 2 of 25 instead of the x minus 9. So see what I'm doing? I'm writing this down, and instead of the x, I'm putting the value that I just got. And you press enter. If it gives you 4, then you are correct. You're doing the right work. Now, before I move on to number 9, 10, and 11, as you can see, I skipped numbers 5 through 8 because that will show you how to do the second type of logarithmic equations. But before I move on to 9, 10, and 11, I would like to do an extra problem with you where the log is actually not isolated and I have to isolate it, okay? So let's do that. So the problem is 7 log base 3 of 2x minus 1 minus 1 equals to 6. Now, remember, my first step is always to isolate the log. So there you go. This is the log. So I need to move the negative 1 to the other side by adding it. So 7 log base 3 of 2x minus 1. This cancels out. And remember, I have to add 1 to the other side. And 6 plus 1 is a 7. So I just move the negative 1 to the other side, but the log is still not isolated. I have also to get rid of the 7. Since it's being multiplied, I divide both sides by 7. So this goes away. Log base 3 of 2x minus 1 equals 7 divided by 7 is a 1. So I just isolated the log. That's my first step. My second step, if I have this type of equation where I have a log on one side and a number on the other, then I have to change it to exponential equation. So 3 to the power 1 equals 2x minus 1. 3 to the power 1 equals 2x minus 1. Now, 3 to the power 1 is a 3. So let's solve for x. To get x by itself, you add 1 to both sides. 3 plus 1 is a 4 equals 2x. Now you divide both sides of the equation by 2 and you get x to be equal. 4 divided by 2 is a 2. So that would be my final answer. Now remember, you always need to check. So go back to the main equation and put this in your calculator. 7 log base 3 of 2 times 2, since x is 2, minus 1, and there's a minus 1 on the outside, and press enter. Is it going to give you a 6? If yes, then your answer is correct. This is how you solve such a logarithmic equation. Now let's move on to number 9. Now, you might ask yourself, oh, I see a log on the left, I see a log on the right, so is this really a log and a number situation? But you see how you have a negative 1? The negative 1 is not part of the log because I do not have parentheses, so I do have a number. Then what is this log doing then? So you need to remember all the log properties that we have learned before, and there are basically 3 of them. Let's write them down. The product property. What does the product property say? If you are adding log x plus log y, then you can condense those two logs into log of x times y. The quotient property tells you if you are subtracting two logs, log x minus log y, then you can condense them into log of x over y. And the power property tells you if you have a number in front of the log, let's say a 7 of log of x, then what you can do is you can push the 7 up and it becomes log of x to the power 7. Now, maybe this property, we're not going to use it a lot in this type of equations because if you have a log on one side and a number on the other, what we usually do is divide by 7 to get rid of it. Like this example here. You see how we have a 7 in front of the log? Instead of taking back as a power and having 2x minus 1 to the power 7, what we can simply do is just divide both sides by 7 and we get rid of that number. So in these type of equations, it's better to just divide by that number in front of the log. Now let's do number 9. Now, yes, I have a log on one side and a log on the other. So what I would prefer to do is to move this to the other side by subtracting it. Since you have log base 4 of x, I'm going to subtract log base 4 of x from both sides. So I end up having log base 4 of 8 minus log base 4 of x minus 1 equals, there's nothing left on the other side, so I'm going to put a 0. Now what you need to do next is move the negative 1 to the other side. So now you have log base 4 of 8 minus log base 4 of x equals 1. So what I did is I moved this log next to the other log and I moved the negative 1 to the other side. So I have a log equal to a number. Now can I condense these two? Absolutely, using the quotient property. If you have a subtraction, it means you have to divide 8 by x. So you can continue this problem by saying that log base 4 of 8 minus log base 4 of x is simply log base 4 of 8 over x. And that is equal to 1. Now you see how we have now log equal to a number? So our next step now is to change it to exponential form. So 4 to the power 1 equals 8 over x. So 4 to the power 1 is equal to 8 over x. 4 to the power 1 is just 4 equals 8 over x. Now what you can do is you can cross multiply. So 4x equals 8. And then you divide both sides by 4 and you get that x is equal to 8 divided by 4, which is a 2. That is the answer. Now remember, what you can do is you can do log base 4 of 2, find that, and then do log base 4 of 8 minus 1, find that, and these should be exactly the same answer. This is how you do number 9. Now let's go ahead and do number 2. Let me just erase over here so I have space to do the work. Okay. Now, it looks like a log and a number situation. You know why? Because I have a negative 2. I have a number. It's not inside the parentheses, so negative 2 is by itself. So what I would do is I move the 2 to the other side. So let's add 2 to both sides. So you have log base 8 of 4 equals, this goes away, minus or negative log base 8 of x plus 2. Now let's go ahead and add log base 8 of x to both sides so I can move all the logs to one side of the equation. So I have now log base 8 of 4 plus log base 8 of x equals 2. Now, if I look at those two logs, there is addition between them. So I remember the product property. And the product property tells you can condense these two by multiplying the arguments 4 and x. So 4 times x is just 4x is equal to 2. Now I have a log on one side and a number on the other. So what I would do is I would change it to exponential. So 8 to the power 2 equals 4x. 8 to the power 2 is a 64 equals 4x. Now to get x, just divide both sides by 4. X equals 64 divided by 4, which is 16. Now don't forget to plug this in the equation and check your answer. Now this is it. This is how you solve logarithmic equations where you have a log on one side and a number on the other.